Okay, this is for specialist maths 6G rational functions. I'm going to sketch this particular rational function. I've shown in the previous explanation video how to turn this into this form. Now that we're into this form of the addition of two functions. So if I'm looking for the x-intercept, I wish to make the original. It's much easier to make the original equal to 0. 0 equals x plus 1 over x. Move the x over 0 equals x plus 1. X equals -1 is my x-intercept. To find the y-intercept, make x 0, so that gives me 0 plus 1 over 0. No solution because there's an asymptote. To find the asymptotes, as I make x approach infinity, this will get down to 0, so the asymptote will be y equals 1, but it will be, this is going to be positive if x is positive, so it's going to be above. And as x approaches negative infinity, this will also go to 0, but it will be a very small negative number, therefore y equals 1 from below. And as x equals 0, then we're going to have a problem, therefore we're going to have an asymptote at x equals 0 and y equals 1. Okay, to find stationary points, I need to take the derivative. So if g of x equals 1 plus x to the -1, g dash of x equals 0 minus x to the -2. Therefore, if I make 0 equal to -1 on x squared, it is not possible for there to be a stationary point because there is no value of x that I can generate that will give us 0 as an answer. Therefore, no stationary points. Okay, so what have we got? I have y equals 1, and I've got x equals 1 on x. Which means when I'm adding them together, I'm moving this up to there, I'm moving this up to there, I'm moving this up to there, moving this up to there. So I end up with an asymptote there, and I end up with a graph that looks like this. And here is my drawing. I've got asymptote at y equals 1. I've got an asymptote at x equals 0. I've got an x-intercept at -1, and I could put in 1 and find out what my other value is. 1 plus 1 is 2, over 1 is 2. So I can put that as being 1 and 2. So there is my curve of the function, which is this divided by x.